Hi there, Ofindic 3363, Christian S, and all the rest of you good people out there. I hope that you're all safe and sound and that health is with you. Regarding your question on the forum on creating a pattern for ribs, kind of diamond shaped here, like in the picture here. In a casted part. I thought that I would follow through and follow up on that as I suggested the algorithmic feature, and as I got the request from elsewhere as well, I thought that I would show how I would do it. In addition, I will add a little bit of a twist to it, as I will actually perform this on faceted data, meaning that we will demonstrate kind of true hybrid modeling, where you mix and match surfaces, sheets, solids, and faceted bodies. And as it is approaching Christmas, I will kind of add here and there some tips and tricks. It will be on the fly, but it's always good to be a backseat driver and check how other people work in order to learn. Okay, so let's see what we got here. I have this request coming in regards to a transmission part or assembly. It's a control case upper. Let's see, now in the 3D viewer here, let's optimize it for CAD lights. So we got this technical data package here, which is a 3D PDF with the assignment described, and also attached are the actual parts that we will be using. Now I have already unpacked those since they are in a zip file, and I put them in a specific folder on my system in order to enable whatever automation is in there. Okay, let's kick it off. So obviously we're focusing on a control case upper, and that is what we will be doing. Seems like someone has gone through a bit of work in order to describe the work. So let's read what's in the highlighted section of this in order to understand what we will be doing. So, in order to increase the operational reliability, the transmission control case upper needs to be modified to handle potential heavy point impact. Okay, yeah, that's kind of, we understand why. A proposal with hex-shaped ribs reinforcing the design is requested. Okay, so that's the red pattern there. Part to be modified is highlighted in orange in the 3D view. Okay, so that's on this side. So this would be the 3D port, and we can rotate and assess the parts. And obviously was the orange part, so let's focus on that guy. Let's isolate that just to see if there are anything in particular that we need to handle. Okay, so it's really nothing in there. It's just the required shape, and we need to add the hex-shaped patterned ribs in the top of that control cover there. Okay, so all files was included. I unpacked them, and if I click the link, that will take me to fire up NX, and we can see that, yeah, normal on most systems, you get a warning opening a PDF file. But as I know where this comes from, I'm safe to open it, so I will go ahead and open it. And it will fire up NX, and it will load those parts that are required. And we will check what needs to be done to these guys here. So once loaded, we can see that we have the whole shebang here. We actually have the whole transmission, which is good. Designing context is always a good way of avoiding potential problems with collisions, etc. And we will check what we were doing. So the control cover is our focal point here. And I would start by sectioning this. But sectioning this, we have the radial pop-up buttons. So if I, for instance, use the right mouse button, if I hold that down, I will get the radial that is under there. And the thing I'm after is the clip section here. And if I do that really quick, well, if I drag and release on the clip section, it's gonna create a section here, or show the section. And if I do it really quick, you won't be seeing that, but the section will turn up. I just want to say that there is no magic behind it. I just customized that button there because I use that frequently. So if I do it quick enough, it will just be a section there. Okay, that's that. Now we can assess the area where the request is, and that is the control cover up here. You can see that we have the control cover, and through the control cover we have a shaft and a mechanism working, meaning that we cannot add those ribs any way we like. We need some clearance to that shaft and the axis there. Okay, so we need to do an analyze. I will analyze the distance from the shaft to the outer cover, and we will have, okay, so that was from the center. We don't want that. We delete the first one there, and we recreate it because I want that to the cylinder surface there. And we can see that, okay, so the clearance is 11 millimeters, and that's what we got to deal with. So that means we can make those ribs, well, not really 11 millimeters, because that would be a little bit too much. Let's say we're going to make them, let's make them 8 millimeters. Okay, so we move ahead and we isolate this in a separate window, just because it's easier to handle. And here we got the control cover, and we need to add some ribs to that, obviously. Okay, so we got some shading on here. We will use just regular shading because we're happy with that. And looking at the geometry we have here, we take a peek in the part navigator, and we can see that it is a convergent body, meaning it's a faceted body, meaning that we need to handle it a little bit differently, and we need to really do a bit of hybrid modeling here, meaning including both probably polygon modeling and reverse engineering for some areas. And we're going to mix that with traditional modeling, except for the algorithmic feature that is fairly new. But we will all move through these steps together, and it will clear as we move along. Okay, so this is a faceted body, and we are going to need the inside and outside to be kind of separated by face, if you like, because we're gonna do a bowl-in operation here, and that will require an inside face and an outside face. So what we'll do is we will, through modeling, polygon modeling, we will replace the top face there, a ceiling face. We're going to replace that with a planar face, and we can see that the highlight is of the planar face to be the orange face there, and we accept that, and it's going to take a little bit of time because it's very heavy on facets here, meaning we have a large amount of them, and we're going to change the shading here. we're going to add so we can see the edges of the faces, and we can see we now have black outline there of that face, meaning that we have an edge there. But we're not done yet. We need to separate the cylindrical faces here as well to get the proper in and outside, and that should be fine, and I'm going to be happy with that, because we could also create a planar face for the bottom here, but I don't really see the point there. I will actually do that as a separate face, because that's going to be base for our hex pattern. So the bottom face here could be a separate one. No, I will not do that. I will actually use reverse engineering. I will use a fit surface. I'm going to do a planar fit to this. Now you could select multi-select by using primitive faces, for instance. Now that has a bit of a tolerance to it, and I kind of want to keep this a little bit more accurate. Hence, I am selecting specific facets where I know that the area is flat. In addition, I'm going to use the vector, in this case Z vector, meaning that that plane is now parallel with the X and Y plane. And that looks good to me. So we say okay to that. That face is a little bit small, so we use the traditional extend sheet, and we now have a big enough face. We're going to create a hex pattern there on that. And this is where the recommendation to use the algorithmic feature comes in. We're not going to take this all the way. You could build the whole thing, the ribs including. But the thing here is we are dealing with convergent geometry, meaning faceted, a faceted body. And in order to do that, instead of the rib function, I will use extrude. Okay, so first things first, we need to create that algorithmic feature and create that pattern. So we're going to do that by evoking the algorithmic feature function there, which takes us into the logic editor, where we have the blank space up here, which is where we create the rules. And we have the bottom down here, which is actually the part, and we can see the graphics. We can see the result of what the rule is actually creating. By preference, it depends on how you like to use it. You have the nodes and rule inputs here. If you expand it, you can scroll through the available rules. Not really necessary, and search is a really good thing to use as far as you know what you're looking for. If not, you might want to scroll through those nodes existing there. Okay, so we know that I want to create a hex pattern here. So we search for hex, and I'm going to create them as cells. We double click on that, and that will turn up in our editor space here. And we see that we have a red node there. That is a hard requirement, means that I will need to satisfy that requirement in order for this to work. Now you can add anything through search. So I want to add a face, obviously. And if you spell it right, it will be correct. You could use face from here. Just double click it and we'll add it to the editor. Or you can right hand click on that node and say create input. Once done, select the actually entity in question and select the entity that is going to be base for this whole thing. We can now see that it's a satisfy requirement here. We don't need to add anything more really, but we want to control in the U and V direction here. About 10 sounds fine to me. And if you want to change the number, you could do it here, or you can change the face of the size of the extension of the face we created earlier. Excuse me. At the top of the feature here, we have a preview, so I can see what I'm actually creating at this stage. We can see that we got a hex shape pattern, which is exactly what we want. And we can go ahead either to create an output, or we can click the polyline cells here, for instance, and we can add the output, which is a good way of adding it. And once we're done, this means that this little symbol rule is all that I want for this for now. You could add it to the reuse library, but this is a simple pattern and it's just for this specific part, so I think that would be overkill. So that means this will reside in this part only. Now you can add, obviously, if we search here, we have, for instance, we have rib, and once again, rib. I got a problem spelling here. Rib. We actually got the feature rib in there. However, that is best suited for when you actually have BREP geometry in there as well. Now this is faceted geometry, so hence I will do this as an extrude in a later operation. You will kind of see why. So we say finish to that, and we're happy with that. That means I have now created my hex shape here, which is good. Problem is that I would like this pattern to be at the top of the rib. Okay, so I will move back in the to the fit surface there, and I will actually move that that face. That, let's see here now. I'll grab it there. That face I want to move 8 millimeters up, and I'll say OK. There we go. Roll back, and we should have everything updating. Great. Right. And as a little twist to this, I'm going to extrude those ribs. It's going to be individual cells, though. Remember, I created this as cells, meaning that the result will be a whole bunch of solids representing every cell. And I want this to be one solid because I'm actually going to unite it and let the unite trim off the excess material there, if you like. So I will continue by creating an extrude. And I'm going to use the face edges of that face and create an extrude that is big enough. It's going to be oversized. It doesn't really matter how oversized, or because it's going to be controlled by the hex pattern later on. We're not going to do an intersect. We're just going to create it. That's going to swallow that whole thing there, and we're now going to create yet another extrude. We're going to base it on the feature curves, and we're going to base it on the hex pattern there. Now this is going to give you a preview, and if you have a big kind of pattern like this, you might, and individual cells as well, you might want to toggle off the preview until you have done all your settings. So that could be a good tip. We're going to start from where that surface is, 8 millimeters up from the bottom, and we're going to do something which is big enough, let's say 15. We're also going to add a draft to this. We're going to do it from the start limit, and since I'm extruding it down, the angle going to be a -1, 1 degree angle there, which is going to allow me to get this out of my tool. I'm going to do an offset. I'm going to do that symmetric, and I'm going to do, 1 is fine. So it's going to offset each cell 1 millimeters to each side. If I hide that convergent body for now, and I'll bring back the extrude there, I can also use the intersect, and it's going to intersect with that body. I could do a preview with that and see where we end up. And here I got my pattern. So let's check firstly so that the draft is correct. And yep, we can see kind of the draft angle there already. Okay, good. we're happy with that, so we're gonna just let the system create that for us. And finally, we are going to unite this pattern with the convergent body there. And let's hide the algorithmic there as well. Okay, so we're going to unite this, and that means we only want the interior cells to remain. Everything that is exterior here, remember we created the inner kind of face representing the faceted body there, and outer and the seal surface as well. So we got one inner and outer side, and they are kind of separated. Still on one convergent body, but separated. Okay, so using Unite, here we also toggle off the preview, depending on how heavy your faceted body is. I'm going to unite that with the hex-shaped ribs here. And I'm also going to define regions, because that will allow me to remove the excessive material or overhang that is on the outside here, if you like. And I want to use remove, and I'm going to remove everything that is on the outside. And then I'm going to let the system run off and create that for me. And well, pretty much that should be it. And there we have our Unite. Now, we might want to reinforce this a bit further. That means maybe we want that pattern to be a little bit more dense. We could do that by edit the algorithmic feature, because if you remember, we added the 10 in U and V direction. So I'm actually going to increase, I'm going to crank it up to 15. Obviously, there is a limit to how many you can have here, depending on the size of that face. We don't want that completely kind of filled, but we do want that to withstand that heavy kind of point impact that might occur to the cover here, and might destroy the function of the transmission here, or transmission control. Okay, so here we go. We have our hex pattern here. Great. If I section that again, we can see, yep, it's there. It's solid. And if I move to the assembly, we can see, yep, we have our clearance of 3 millimeters there. We're happy. And well, I think this is what we will send back to our customer so they can evaluate if this is what they want. Okay, that's all I wanted to show and convey for now. And with that, I'm going to leave you for tonight. And I hope that you are all safe and sound out there. And above all, that you stay healthy. So that's all from me for now. And over and out from Fred. Bye for now.